Welcome back. Today is day 7 of our angles relationship unit. Today we'll be proving alternate and same side interior angle relationship. This will wrap up the angles pairs unit. Hope you enjoyed the video. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Do now. So it says find the measure of all missing angles, then complete each statement. So this shouldn't be too bad. So if we have 60 degrees, I know I can use a linear pair to find the one next to that one. So that's going to be 120. I can use vertical angles twice to say, okay, this is 60, this is 120. And then I can use corresponding angles to write those ones all up on the upper half of this graph. So we'll go 60 there. We will go 120 underneath. So this should all be reviewed for us. 120 again and 60. All right, perfect. Let's do the same thing with the second one. Let's do a linear pair going upwards. So let's say 75. So this must be 105. Vertical angles is 75. Vertical angles is 105 again. So again, each one of those shouldn't be too bad. And let's use corresponding angles to move these down. So 105, 75, 75, and 105. All right, perfect. So now let's answer the question. I noticed that alternate interior angles something. So let's take a look at alternate interior angles. Remember, interior is going to be between those two lines, and alternate means we're going to switch sides. So I'm going to circle this angle and this angle. And let's circle the other pair also. So let's circle the 60 and the 60. All right, perfect. So I circled two pairs of alternate interior angles. And what do we notice? I noticed that alternate angles are equal. Perfect. All right, so that's what we should be noticing right now. Let's try the next one. Let's see what the next one says. And you can look below also at the 75 and 75 and 105. So that also works there also. But let's read the next statement. I noticed that the alternate exterior angles, well, let's take a look. Alternate exterior is going to be the ones on the outside. And they're going to have to switch sides, the transversal. So this one and this one. And these are my alternate exterior angles. And what do we notice about those ones? Well, again, we notice that they are equal. They are equal. Perfect. All right, so what we're going to do now is, now that we notice, we want to see if that works all the time, and let's see if we can prove that. Let's see if we can prove that alternate interior angles are equal. All right, we're going to do that next. Let's try to prove that alternate interior angles are equal. So let's see. How are we going to do that? Well, first of all, we need to identify what are we trying to prove. So in this problem, we are going to try to prove that angle 3 is the same as angle 6, so that those measures are equal. All right, but then once we do that, then we need to also prove that 4 is equal to 5. So we're going to try to prove that also. So we're going to have two things we need to prove, and I'm going to write that down right now. So I'm going to try to prove that the measure of angle 3 is equal to the measure of angle 6. And then second, the next time we do this, I'll let you guys try that one. The measure of angle 4 is equal to the measure of angle 5. All right, perfect. So now, how are we going to do that? How are we going to try to prove? Let's do the first one. How do you prove that the measure of angle 4 is equal to the measure of angle 6? So here's what your thinking should be. You should be like trying to think, there's got to be a way I can say that angle 3 is equal to angle 6. All right, and now usually it's going to take a few steps to get there. And think back to, if you watched my earlier videos, think back to the dad is old problem. So remember back before we said, well, dad was old people die, so that means dad's going to die. So we have to sometimes use that kind of logic to connect these ideas. So let's see if we can do that in this picture. And we can mark the picture up and then actually try to write it in a second. So is there a way you can connect angle 3 and show that it's equal to angle 6, but maybe you connect it by going some other way, like saying it's equal to other things? So in this problem, is there anything that you know angle 3 is equal to? Well, if you've been studying this unit so far, you should know that angle 3 is equal to angle 2. And how do we know that? Well, angle 3 is equal to angle 2 because those are vertical angles. But then we can now connect angle 2 to angle 6. So now we can say angle 2 is equal to angle 6 because of what? Well, that's because of the corresponding angle postulate. So now we just did a little link. So we connected 3 to 2, and now we connected 2 to 3, or 2 to 6, which implies that we can say now 3 is equal to 6. Does that make sense? So it's kind of like the same problem. Dad is old people die, then that means dad's gonna die. All right, so if you refer to the earlier videos, then you probably remember that one. So let's see, how do we write that down? So in this problem, remember what we always start off with. And actually in this problem, I think I'm gonna start with the part that I'm gonna start with angle 3. So I know that the measure of angle 3 is equal to the measure of angle 2. And what was the reason we said we knew that? How did we know 3 was equal to 2? How do we know 3 was equal to 2? Well, those are just vertical angles. And we actually have a theorem. We actually proved that one, so that's the vertical angles theorem. Perfect. So we actually have a theorem for that one. Now the next part. Now we need to connect angle 2 with angle 6. And so I'm going to write it right here. I'm going to skip the first box, and hopefully you understand why. So the measure of angle 2 is equal to the measure of angle 6. And how do we know that? Well, we said angle 2 was equal to angle 6 because of the corresponding angles postulate. Corresponding angles postulate. Remember, we did not prove this one. We just said, okay, this is given to us. We assume it's all true. All right, so that's a postulate because we didn't prove that one. The vertical angles is a theorem because we did prove that one. But now, what is this box above the corresponding angles postulate, and why is it there? Well, remember, there was something that must be true for the corresponding angles postulate to work. Remember, there was an if and a then. It was like if something, then the corresponding angles are equal. But there was something first. So if something, there had to be something true already. And again, this is why they gave you something at the very beginning of this problem. This is why at the very beginning of this problem, they said, hey, you are given some parallel lines. So we are given in this problem, line L is parallel to line M. And how do we know that? It was just given to us. They said, hey, this is true. Because think about it. Angle 2 is not equal to angle 6 unless the lines are parallel. That's the only time they're equal, if those lines are parallel. All right, so that means you need to say that in your proof. You actually need to write that down. So again, that's why we had to have a statement before we said angle 2. Now, going back to angles 2 and 3, do we need parallel lines to say that 2 is equal to 3? Like, do you need a reason to say, like, well, 2 is equal to 3? No, you don't need parallel lines. Vertical angles are always equal. We already proven that one. We don't need parallel lines for that. We didn't have any constraints before we started that problem. So that's why one of these has a statement before and the other one doesn't. All right, but now we get to put these together and we can write our answer. So, oh, I messed something up. No, I didn't. So here we go. Take a look. Measure of angle 3 is equal to measure of angle 2. Measure of angle 2 is equal to measure of angle 6. Well, now we can conclude that the measure of angle 3 is equal to the measure of angle 6. And what is our reason? That was called the transitive property. And we are done. So we have proven now that our alternate interior angles are equal. And we're going to the theorem here. Alternate interior angles theorem. So now we get to write a theorem. So if, remember, something must happen. There was something that must be true or this doesn't even work because we had one given. So if line L is parallel to M, so let's write that out in words. So if two lines are intersected by a transversal. So if two lines are intersected by a transversal, basically saying you have two lines that are parallel, and we knew there had to be a transversal in there. So if two lines are intersected by a transversal, then our conclusion was alternate interior angles are equal. Perfect. Okay, and that's it. That's what we're trying to do. So now, from now on, whenever you see parallel lines, you can look at the alternate interior angles and you should know that they are going to be equal every single time. All right, the same thing is going to happen with this next part. You can prove the alternate exterior angles, same kind of pattern, same kind of flow in the proof, but let's just write it down because otherwise this video will be too long, and it's already going to be long. So I'm going to just copy this down. So if two lines are intersected by a transversal, then what's your conclusion? Then guess what? I'll write it again. The alternate exterior angles are equal. All right, so again, you would have to prove that on your own. So you're going to have to go back and actually prove that on your own, but it follows the same pattern. You're going to use the same kind of transitive property to kind of do this problem. All right, same process now, and we're going to do the same thing about this time, focusing on same side exterior angles and same side interior angles. I've already solved these problems already for you, so that way it's quicker. But what we should notice is, what do we notice about the same side exteriors? I should have done the other order because I have those sentences in different order, but these ones, so I've color-coded those ones, and then also the same thing for the same side interior, so these ones in here. Perfect, so they're on the same side of the transversal, and they're interiors or exteriors. And now when you notice, when you circle both of those, we should notice, well, guess what? 130 plus 50 is 180. 50 plus 130 is 180. 110 plus 70 is 180. So we notice every single time what's happening here. These are supplementary. So these add up to 180. So that's what we should notice. So for both of these, so guess what you're going to have to do now? You are going to have to prove that that is true. Prove that those same side interiors and the same side exteriors add up to 180. Problem is going to be very similar. So we are given two parallel lines again. We need to prove that the same side interior angles are supplementary. So in this problem, what I'm looking for is I need to prove that angle 3 plus angle 5 is equal to 180. And then after that, we'll do the same thing with its the ones next to it, so 4 and 6. So I'm going to write that down. So I want to prove this time the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. And then also we are going to prove separately in a whole separate proof, but I'll let you try that. That'll be the one I'll let you guys do. Angle 6 is equal to 180 degrees. Okay, perfect. So now let's start this problem. So how are we going to start this again? So our job today is to figure out how do we get angle 3 and angle 5 to say, hey, those are equal to 180. Well, this is going to be different than the last problem. We don't need to say, hey, these are equal to each other. We don't need to connect them that way. But we're going to have to connect this problem a different way. So one thing I would be looking for right now, is there any way I can use angle 3 or angle 5 to show that I need to get something else that adds up to 180? Because if I can find something that adds up to 180, then I can start switching and swapping things out. So when I look at this problem, first thing I would see, you can do it different ways, but we should notice angle 3 and angle 1 add up to 180. So if I look at angle 3 and angle 1, I'm like, well, I know those add up to 180. And now, is there any way we can connect this to angle 5? Is there any way we can connect 3 or 1 to angle 5 now? Well, guess what? We notice here angle 1 is corresponding to angle 5, which means that angle 1 is equal to angle 5. And so we can just do a little swap. So let's go ahead and write all this out and see what this looks like. So let's go back to the beginning. So first thing I would say in this problem is I would say angle 1, or I would start with angle 3 since my proof says that. Angle 3 plus angle 1 is equal to 180 degrees. And how do you know that? What would your reason be for this problem? Well, I would just say that's the linear pair postulate. That's what we learned a while ago. Okay, so we know that those add up to 180. And we also know that, so again, I know that these two right here, these two add up to 180. That's going to add up to 180 degrees. All right, but we also know that angle 1 is equal to angle 5. So we know angle 1, like I started with blue this time, so the measure of angle 1 is equal to the measure of angle 5. And how do we know that? Well, that would be because of the corresponding angles postulate. But again, just like last time, you cannot use the corresponding angles postulate unless you said something else before, unless these lines were parallel. So we need to say that. It was our given, and we haven't used it, but we need to say that. We need to say lines L and M are parallel, and we know that because it was just given to us. Now, because the lines are parallel, then the corresponding angles postulate works. It doesn't work without parallel lines. All right, perfect. Now look at your two statements here. You have two statements here, and I see that I can swap out measure of angle 1 and replace it with something else. So let me start writing this and show you what I'm going to do here. So the measure of angle 3 plus this part is going to be replaced. That should be a measure of angle 1 is equal to 180. But I'm going to replace that with the measure of angle 5. And I'm doing that because I know 1 is equal to 5. We've already said that. We said 1 was equal to 5, so I can swap it out. And now, what would our reason be for that? That would just be substitution. We just did a little substitution, and this one came there, and this one came there, and this goes there. All right, and we're done. We have proven that the measure of angle 3, now we've said angle 1, this one over here, is equal to angle 5. Those are equal to each other. All right, not too bad, not too shabby. So again, you can do angle 4 plus 6 on your own. Same kind of reasoning, same kind of problem. But let's go ahead and write a theorem for this and wrap this up. If you've proven, like we've done the first one, you had to prove both angles. But if you did both pairs, then you can say same side interior angles theorem. So now we have a theorem we can work with. So let's go ahead and write this down. So if, what was your condition? We needed two lines intersected by a transversal. So whenever this happens, whenever you have two lines intersected by a transversal, then what do we know now? Whoa. Then what do we know? We know the same side interior angles are supplementary every single time. So as long as two lines are intersected by a transversal, then you can find those same side interiors and you know that they have to add up to 180. All right, this next part will be exactly the same. If this will be the exact same, then this will be the exact same, except for what? Exterior angles. Okay, and you can do the proof. It's going to follow the same kind of format, same kind of flow, but you can prove that on your own. So now, I lied. Let's wrap this unit up. I said we were almost done, but we're almost done now. So unit summary. So what were we supposed to learn in this chapter? We're learning all about angle pairs. So we're looking about pairs of angles, and we had some relationships, and they really broke down into three categories. We had things that add up to 90 degrees. We had pairs that added up to 180 degrees. We had pairs that were equal to each other. And let's go ahead and write those down. And this is basically a nice little graphic organizer, a nice little summary for you of what you're supposed to know in this chapter. So name some things that add up to 90 degrees. Well, there was only one. It was complementary angles. So pairs of angles, two angles, if they said they were complementary, they add up to 90. That was the whole definition. Now, what about things that add up to 180? Well, this we have a few options. First of all, you know the definition, so you know supplementary just means two angles that adds up to 180 degrees. But there was other things now. We just learned two more, like just literally right now. So we should also know the same side interior angles. Those will add up to 180, but we have to have parallel lines. So that only works if we have parallel lines. And the other one is if we have parallel lines, we have the same thing, the same side exteriors. Okay, but there was one more pair of angles that added to 180 in this one, and it didn't rely on parallel lines. It just always worked. It was the linear pairs. Okay, again, we're still having trouble with these ones. Holy moly. Linear pairs. Okay, so linear pairs also add up to 180. So there are four types of angles that you should know always add up to 180. Supplementary angles, same side interiors if the lines are parallel. That's the key, it has to be parallel. Same side exteriors if the lines are parallel, and linear pairs always. All right, now what kind of angles are equal to each other? Well, angles that were equal to each other that we studied in this one was, the first one was vertical angles. So vertical angles are always equal to each other. Now, there were some other angles that were equal to each other if the lines were parallel. So let me write those ones in. So if the lines are parallel, then there was the alternate interior angles, and there was also the alternate exterior angles. And you will be using these over and over again throughout our problems. Okay, so this basically is your wrap up of the unit. We need to know complementary angles add up to 90. We need to know the four that add up to 180. We also need to know that the ones that are equal to each other, vertical angles and alternate interiors. Oh, and I forgot one more. We use this one all the time. The corresponding angles. But again, this is only if the lines are parallel. So I put a little symbol in front of them. If the lines are parallel, only if the lines are parallel do some of these work. All right, hope you like this unit. We're all done. Good luck.